Hi, this is Mr. Krieger, and this is going to be lesson 1 of Algebra 1. And in class, we're going to do these pages. So when I meet you on Monday morning, we're going to do these pages together. You might want to either look at or print up this. We're not going to do, this is going to be your homework. And you have to decide how you want to print up the materials. But what we're going to do is, in this video lesson, I'm going to start with this page. I'm going to do these pink circled problems here. Kind of a review of stuff that you probably did even in pre-algebra, stuff that you're probably comfortable with. I'm going to skip this question. I think you guys are all good with this. Let's start with a question like number 2. All right, so this is an equation, 2 parentheses m plus 6 equals 48. Now, what you need to do is you need to distribute that 2. Through the parentheses. So it's going to become 2m, and 2 times 6 is 12, plus 12 equals 48. And then you know at this point, you need to isolate the variable, subtract 12 from both sides. So now you have 2m equals 36, divide by 2, and I'll put it over here, m equals 18. All right, so you should be pretty good with solving an equation like that. Here, we have a slightly more complex equation. We still want to deal with the parentheses first by distributing that 3. 3 times 2x is 6x. 3 times negative 1 is negative 3. And then the parentheses have gone away, but we still have a minus 10 on this side. Okay, equals 8 plus 5x. Now, the next thing we want to do is we want to combine like terms. Well, let me just do one thing here. The like terms on this side are negative 3 and negative 10. And you could literally just do on your calculator, negative 3, you get the negative from here, minus 10, which becomes negative 13. So we have 6x minus 13 equals 8 plus 5x. I'm going to continue that on this sheet of paper, so I have more room. So now we have, now that like terms are on opposite sides, what we could do is, for example, add 13 to both sides. But remember, when you add the 13 to both sides here, it's going to be, this is going to cancel, but this is going to be 6x on this side equals 21 plus 5x. And then we're going to want to subtract the 5x from both sides, and you get x equals 21. I'll put that over here. Okay? Now, in our next problem over here, we have like terms on the same side. So if you notice, we have an 8x and a negative 3x. So these are like terms, the 8x and the 3x with the negative. And we can combine those. 8x plus negative 3x, or 8x minus 3x is 5x. So we get 5x plus 9 equals, and on this side, we have the 8 and the 1 are like terms, so that could become 9. We get 9 plus 5x. Okay? And now, what we're going to notice in this problem is if we subtract 5x from both sides, the x's cancel out. We get 9 equals 9, which means in an equation like this, we're going to have all values of x are going to work in this equation. You put any number in for x, 1, 2, 10, negative 5, and it will satisfy this equation. So really every value of x is a solution to this equation. That's what happens when the x's drop out and the two sides are equal to each other. Now, if the two sides were not equal to each other, then you'd have a scenario where no values for x would satisfy the equation, okay? But the emphasis I wanted to make on this problem was combining like terms on the same side of an equal sign is just adding them or subtracting them, depending on whatever signs you have there. All right, in this next problem, which I'm going to actually do over on another page, is that we are going to want, and I'm going to write this a little larger, and I'll do it over here. We're going to want to distribute that negative sign. In fact, if you prefer, you could put a little negative 1. You could put a negative 1 in front of the parentheses. And you'll basically be distributing that negative 1 through the parentheses. So you still have the 8a, but now you're going to get negative 1 times 4a is negative 4a, And negative 1 times 32 is minus 32 equals 16. Now you can combine these like terms on the same side. That's 8a minus 4a is 4a. Add 32 to both sides. You get 4a equals 48. Divide by 4 on both sides, you get a equals 12. I'll write that over here, a equals 12. Okay, so that's how you tell a problem like that. All right, now let's take a look at even a more complex problem, which again I'm going to do on a separate sheet of paper over here, just so that we have room. So here we have multiple parentheses. I'm going to rewrite it. 4 parentheses x plus 5 equals 3 parentheses x minus 2 minus 2 parentheses x plus 2. And again, you're going to want to eliminate all these parentheses by doing the distributive property through the parentheses for each of these problems. So 4x, 4 times x and 4 times 5, you're going to get 4x plus 20 equals, we're going to distribute that 3 through the parentheses. That's going to give you 3x minus 6. You're going to distribute that 2 through the parentheses. That's going to give you negative 2x minus 4. You are going to want to combine like terms. On this side, there are no like terms. But on this side of the equation, you have the 3x and the minus 2x. That's going to combine to give you 1x. And negative 6 minus 4 is minus 10. You can do it on your calculator like I did before. You know, negative 6, you put in the first one as a negative with this button. And you can subtract off 4. And it gives you negative 10. That's how we got negative 6 minus 4 is negative 10. This side of the equation wasn't altered in any way. And now we have an equation where there are different terms on each side. To get the like terms together, you could subtract x from both sides. So you're going to get 3x plus 20 equals negative 10. Subtract 20 from both sides, and you're going to get 3x equals negative 30. Divide by 3, and you get x equals negative 10. So the answer for this one is x equals negative 10. I skipped a few problems, and you're free to try them on your own. And then you can ask me if you have any questions in our next Google Meet, the one on Tuesday. If you have any questions about this, I can go over any of those problems with you. All right, let's take a look at our next example. This one has a few different kinds of parentheses here. We have a situation where, I'm going to use a different sheet under this. Okay, we have a situation where you have 6x minus, and then you have a bracket, 2x plus 3 parentheses x plus 1, close parentheses, close brackets, equals x plus 20. The reason for the brackets is merely because what we want to do is we want to, when you have parentheses within parentheses, it's easier to see what's grouped together with brackets instead of parentheses when there's multiple brackets or parentheses together. So here the x plus 1 is in parentheses, and then this whole thing is in brackets. So this way you can identify which part belongs to which. The first thing I'd like to do though here is put a minus 1 in front. And I want to distribute that negative 1 through the terms. And don't distribute it through this parentheses. It's just going to go to whatever main terms are in here. So what's going to happen, 6x is going to still be here, but the negative 1 times the 2x is negative 2x. And the negative 1 times this is going to give you negative 3 parentheses x plus 1. We haven't dealt with those parentheses yet. We've just dealt with this pair of brackets by distributing. And I'll just write down what we have on the other side. We still have other things to do. Let's get rid of these parentheses by distributing the negative 3 throughout. I'll bring this stuff down, those combine, so that's going to become 4x. And then we'll distribute through these parentheses. You're going to get minus 3x minus 3 equals x plus 20. We can combine some more. 4x minus 3x is x, so we get x minus 3 equals x plus 20. And now we're gonna have the situation here where you subtract x from both sides. You have no x's left. You have negative 3 equals 20. Now, that is not a true statement. Since the x's dropped out, any value for x that you substitute into the original problem is going to fail to work. So there are actually no solutions to this problem because these two sides are not equal and the x's have dropped out. So there are no values that are going to satisfy this equation when you plug them into the original problem. So in this problem, we say there are no solutions. So let's compare these. In problem number 9, we found that there were no solutions when the x's dropped out and there was nothing, and the two sides were not equal to each other. And when the x's drop out but the two sides are equal to each other, we would say all values of x are solutions. All values are solutions. Okay, so you can see a comparison there between a situation where x's drop out but what's left over are equal, all solutions are valid, and a situation where the x's dropped out but the two sides are not equal. In this case, there'd be no solutions. Okay, now what we're going to do a little bit at this point is we're going to see how to work with these fractions. What if you have fractions? Now, I know a lot of people aren't really comfortable with fractions, but you have the benefit of having the graphing calculator. And what you should do is, if I want to distribute the 1/3, this 1/3 through the parentheses. So basically I'm doing 1/3 times 21, and then 1/3 times 3x. I left the minus in there. If I don't know how to do this multiplication with fractions, what I could do is I could put 1/3 in my calculator. And the way you could do that, if you do alpha y equals, you could make a fraction, press enter, it's the first thing, and you could put in 1/3, and then put parentheses here, because it's like a or even if you want to put a multiplication here, times, and you don't even need parentheses, 21. Let's see what that yields. That gives us 7. So this product gives us 7. The next one, you could do the same thing. You could put the minus here, and 1/3 times 3x is going to be whatever, but the minus is still going to be there. So 1/3 times 3, what do you think that's going to be? Again, if you're not sure, you could do alpha y equals, press enter. You could put in the 1/3, or negative 1/3, whichever you prefer. And you want to multiply that by 3, just the coefficient, not the x, just the 3, and it gives you 1. So this is essentially 1x. Now you could do the same thing on this side when you just distribute through the 1/2. 1/2 times 8 is 4. And you could check that on your calculator. 1/2 times -4 is -2. Now we have a situation like the previous ones where we have unlike terms on opposite sides of the equation. We could fix that by adding 2x to both sides. Again, you have various options here how to proceed. You're going to get 7 plus x equals 4. If you subtract 7 on both sides, you're going to get x equals -3. Okay, so that's how you solve these problems. Now, on the next page, what I'd like to show you, is other problems that have fractions in them and how we deal with them. In a problem like this, 4/5 y plus 4 equals 16, just like you normally would, isolate the variable. By subtracting 4 from both sides, you're going to get 4/5 y equals 12. Now, in this problem where the coefficient of y is a fraction, we're going to use a different technique. I want to compare this to this last problem. In this last problem, the coefficient of x was never a fraction. It was always a whole number. Here it was a whole number. Here it was a whole number. Even here it was a whole number. We never had a number in front of the x, a coefficient of the x that was a fraction. But in this problem, we do. Best thing to do with a problem like this is to use the multiplicative inverse property. Now, you might not remember what that is, but this is what you should do. You have a fraction in front of the variable. Normally, you divide by whatever is a coefficient of the variable. And you could do that. You could divide both sides by 4/5, but this is probably a better technique. Multiply both sides by the reciprocal, or the multiplicative inverse of 4/5. In other words, multiply both sides by the flip, the reciprocal of this fraction. 5/4 on this side, 5/4 on this side. This will cancel out. Why? 5 times 4 is 20. 4 times 5 is 20. 20 divided by 20 is 1. This is essentially a 1, and you just get y on this side. On this side, we have to do 12 times 5/4. No problem. In your calculator, you can do 12 times, and you can go to alpha y equals. Put in your fraction there. Put in 5 and 4. 5 divided by 4, 15. So here you get y equals 15. So it's pretty easy to work with fractions if you use this technique. I'll skip around a little bit. We'll take a look at a couple of more problems of this. So here we have -1/3 x minus 2 equals 10. Add 2 to both sides. You want to isolate that you want to isolate the x, the variable. Multiply both sides by the reciprocal of this, which in this case is going to be negative 3 over 1. Even the sign is going to stay the same. So if this has a negative sign in front of it, then the reciprocal is also going to be a negative. That's the multiplicative inverse. Multiply this side by the reciprocal, but whatever you do to one side of an equation, you must also do it to the other side of the equation to balance the equations. This will divide out and become x, which is essentially have a coefficient of 1. And 12 times negative 3 over 1 is negative 36. So that is going to be your answer, okay? So let's jump to number 4. Again, you could try these other problems if you like on your own for practice, and you can ask me on Tuesday's Google Meet if you want to go over these at all. Let's take a look at this one. We want to isolate that variable c. There's a 1 here. Let's subtract the 1 from both sides. We get negative 2/5 c equals 8. And you know what to do here at this point. Multiply by the reciprocal on both sides, the reciprocal of this coefficient of the variable, which is going to be negative 5/2. Okay? This side is going to divide out to 1, so you're just going to get c. On this side, we can put that in the calculator. Let's see. We got 8 times, I'll put parentheses, and we'll do alpha y equals, and we'll put in, we got to press enter, and we'll do negative 5 divided by 2. No, I don't want that there. I'll put the parentheses there. Let's see what that gives us. It gives us negative 20, and we get c is negative 20. By the way, if something I said is a little confusing or if I'm going too fast, one of the nice things about a video is you can pause the video, you can rewind it, you can watch something again, pause it at a particular point, take a look at what I'm doing. That will be a very helpful technique for you if you're a little confused. All right, so now the last thing we're going to cover today is going to be, we're going to skip this page. It's more of the same. And again, you're welcome to do this for practice. I would probably try a couple of them just for practice, like the ones we have done. The last thing we're going to do today on the last page of the lesson is when we have two fractions equal to each other. We call these proportions, right? And in a proportion, we know the product of the means is equal to the product of the extremes. Basically, that means cross multiply. Well, this time I'm not going to use my thick pen, but in this proportion when we have 15 over x equals 12 over 10, we want to multiply those and those, 15 times 10 and 12 times x. I'll start with the 12 times x, which is 12x, and 15 times 10 is 150. So now we're just going to divide. I don't know if you can see that, so I'll rewrite this in my darker marker. Divide by 12. 150 divided by 12 is 12.5. X equals 12.5. Now I know that's not pretty simple, but I want to show you a couple of other problems. Like, for example, this only had monomial terms, 15x, 12, 10. But here in the second problem, we have a binomial here. So how do we deal with that? Again, we're going to cross multiply, but watch what the difference is going to be. This is what I suggest or recommend that you do very strongly. 5 times x plus 4, do 5 parentheses x plus 4. Rewrite the whole thing in a straight line in one equation where you haven't distributed yet. Because I know a lot of people will do 5x plus 4. That's not going to be correct. It's 5 parentheses x plus 4. The other side is easy. 2 times 20 is 40. Now you got to distribute that. So you don't get 5x plus 4, but rather you get 5x plus 20. Now you can continue that, subtract 20 on both sides. You get 5x equals 20. Divide both sides by 5. X equals 4. Okay? Let's do one more. Let's take a look at a situation. Actually, maybe we'll do two more. Let's take a look at a situation here. We have two binomials. So again, what we want to do is we want to cross multiply and follow my recommendation. I not only highly recommend it, I urge you to do it because this way you will avoid mistakes. So 5 parentheses 2x plus 10 and 15 parentheses x minus 3. Now you can distribute. So you're going to get 10x plus 50 equals 15x minus 45. You have like terms on opposite sides of the equation. So, we can subtract 10x from both sides. And we get 50 equals 5x minus 45. Add 45 to both sides. And we're going to get 95 equals 5x. And if you divide both sides by 5, you're going to get x equals 19, okay? That's how you deal with proportions. Let's just take a look at this one last proportion, only because there's one slight difference. It doesn't look like a proportion. We have a fraction on this side, but we have a whole number on this side. Well, I would make this into a fraction by putting it over 1, and then you can still cross multiply. This one's an easy one once you do that. 1 times parentheses 21 minus x equals 2 times x is 2x. You could distribute that 1, but you're just going to get 21 minus x, and keep in mind that when 1 distributes through, 1 times 21 is just 21, 1 times negative x is just negative x. You just lose the parentheses here. We still have to isolate get the variables together, so we're going to add x to both sides. 21 equals 3x. Divide both sides by 3, and you get x equals 7, okay? So that's how you deal with a lot of fractional types of equations. So I hope that this is okay. You're going to work on your homework, which includes the stuff that we did in the Google Meet on Monday, plus what we've learned in this video lesson, okay? Until next time.